Revis here. In this video, I will show you how to carry out calculations involving subatomic particles. Specifically, I will show you how to calculate the number of protons, electrons, neutrons, and the mass number, which has historically been known as the atomic mass number. Atoms are composed of three subatomic particles. Protons and neutrons form the nucleus and accounts for mass. Electrons surround the nucleus and account for size. Shown here is a diagram where we have the nucleus containing neutrons and protons, which accounts for the mass, and the electrons surrounding the nucleus, which accounts for size. Note that protons are positively charged and account for mass, and they have a fixed value. Electrons are negatively charged and account for size, but have a variable value. Neutrons, which has no charge, accounts for mass and has a variable value. This periodic table shows you a general schematic of what it looks like to have the nucleus, which contains neutrons and protons, shown in blue and red respectively, surrounded by the electrons. The periods along the periodic table give the various levels where the electrons are housed. The characteristic identity of each element is based upon a fixed number of protons defined on the periodic table as the atomic number. The number of electrons equals the number of protons for all neutral atoms. Elements on the periodic table are neutral atoms, and therefore the number of protons and electrons of each element on the periodic table are equal. Mass number, M, is the mass of the atom based upon its specific isotope. For example, C12 has a mass of 12, C13 has a mass of 13, and C14 has a mass of 14. In this presentation, mass number will be referred to as M or simply mass. So, to summarize thus far, protons equal atomic number, electrons equal protons for neutral atoms, and neutrons equal mass minus protons, or mass equals protons plus neutrons. So, let's start to put these concepts to practice by showing you some examples. Let's start with carbon. Shown here is what carbon will look like on the periodic table. The example we'll start with is carbon with an isotope of 12. Therefore, it has a mass number, or simply abbreviated mass in this presentation, of 12. It's important to note that this mass number is not the same value as the atomic mass unit shown on the periodic table. So we have carbon 12 with a mass number of 12, and if we take a look at its atomic number, we'll note that it is 6. Therefore, the number of protons equals 6. Since this is a neutral atom, the number of electrons equals 6 also. The neutrons are easily calculated by subtracting the mass number of 12, which was given, minus 6, which is the number of protons, to equal 6. And this is what it would electronically look like. You would have the nucleus containing 6 protons and 6 neutrons surrounded by 6 electrons. If we look at isotope 13 for carbon, that is C13, that means it has a mass number of 13. The number of protons do not change. They always equal the atomic number. And since this is a neutral atom, the protons equal electrons to give you 6. The number of neutrons are easily calculated by subtracting the mass number 13 minus the protons for 7 neutrons. If we continue on with carbon 14, for the isotope of carbon, this would give us a mass number of 14. Number of protons do not change from 6. Number of electrons do not change. But because we have a higher mass number, the number of neutrons has increased to 8, and that corresponds to the diagram shown here. This summary slide shows you what each of the well-known isotopes of carbon would look like side by side. Note that carbon 12, 13, and 14 increases from 6 to 7 to 8 neutrons respectively, with no change in the protons and no change in the electrons. Let's take a look at chlorine. Chlorine has two naturally occurring isotopes. Chlorine 35 is a major isotope and chlorine 37 is a minor isotope. The number of protons equals 17 because the atomic number equals 17. Since it's a neutral atom, the number of electrons also equals 17. The number of neutrons is easily calculated by subtracting the number of protons from the mass number of 35 to give you 18 neutrons. And the diagram shows here the nucleus containing the 18 neutrons and 17 protons surrounded by 17 electrons. For chlorine 37, which has a mass number of 37, we note the number of protons do not change, the number of electrons do not change. However, since we have a higher mass number, the number of neutrons increases by 2 to 20, and the diagram shows 20 neutrons and 17 protons in the nucleus surrounded by 17 electrons. Thus far, we've looked at neutral atoms, but not all atoms are neutral. Let's take an example of what happens when we have a charged ion. Let's take a look at what happens with oxygen, for example. And in this example, we're going to reduce oxygen from oxygen in its elemental state of 0 to oxygen minus 2. Oxygen in its neutral state has 8 protons, 8 electrons, and 8 neutrons. And that gives us a diagram shown here with 8 protons and 8 neutrons in the nucleus surrounded by 8 electrons. When we go from oxygen in its elemental state of 0 to its reduced form of minus 2, we add electrons. That means that we have the original 8 electrons plus 2 electrons to give us a total count of 10 electrons. Note, however, the number of protons do not change, neither do the number of neutrons. To summarize, the number of protons remain fixed. The number of neutrons do not change. However, there was an increase by 2 in the number of electrons. Let's take another example, the oxidation of boron to boron plus 3. Because of its atomic number, the number of protons is 5. The number of electrons also equals 5 because it is neutral. The number of neutrons equals the mass number minus the number of protons to give you a total of 5, as shown in this diagram. In the oxidized state, we subtract electrons, and therefore we subtract 3 electrons from the 5 original electrons for a remainder of 2. So boron plus 3 has 5 protons, 2 electrons, and 5 neutrons, as shown in this diagram. And again, to summarize the rules, protons are fixed. The number of neutrons do not change. However, the number of electrons will change based upon the magnitude of the charge. There you have it, an approach to calculating the subatomic particles, protons, neutrons, and electrons.